Okay, hello everyone and welcome to the very first lesson on geometry, which is angles and parallel lines. So today what I'm going to talk about is the basic interactions between parallel lines and what we call the transversal. So this is going to be the topic of this lesson. And before we begin, what I want to do is just define a few things that are going to help us along the way. So the first thing that I'm going to define is the rule that says that any two angles that make a straight line, like these ones here, this angle here and this angle here, and they've made a straight line, they add up to 180 degrees. You may already know this, and there's a really good reason for it. It's that this is essentially half a circle, and as we know, a circle's angles add up to 360. So half a circle must add up to 180. The next thing I'm going to define is that the way that we name angles. So it's not so much a definition as more of a rule of how we name them. It's a nomenclature that we use, to use a more complicated word there than I needed to. And what we say is that when we draw an angle, or when we name an angle, so I'm going to draw some here just by drawing two straight lines. Oop, that one wasn't very straight, that doesn't matter too much. Whenever we name an angle, like we do here when we have two lines that cross, we name it by naming 3 points. So here's point A, here's point B, and up here is point C. Now, to name this angle in here, all I have to do is imagine that I'm drawing a line through these 3 points, through point A, point B, and then up through point C. And if you imagine that I draw that line through A, then through B, and then through C, I would have drawn that angle there. And so I can name the angle by using these 3 points. So I would say that this point here is angle. Here's my little symbol for angle. Angle A, B, C. And we can do that for any angle, and we don't have to use points A, B, C as well. We could do D down here. And then if I wanted to name this angle in here, I would name it by going angle C, B, D. So this angle is angle C, B, D. Like that. So those are the first two things that I need to know to be able to talk about angles. Now the next thing I'm going to do is draw two parallel lines. So just to remind everyone, a parallel line is just a line that is going in exactly the same direction as another line, and therefore will never touch that first line. So that makes a lot of sense if you think about it. If these two lines are going in exactly the same direction, and I stretched them out and kept stretching and stretching and stretching, they'd never touch each other because they're not tilted in such a way that they're eventually going to cross. They'll never ever touch. And so over here, I'm going to define parallel lines as lines that are going in exactly, almost spelt that incorrectly. I'm a maths teacher, not an English teacher. Exactly the same direction. Now the next thing I'm going to do is I'm going to draw in what's called a transversal. Actually, before I do that, I've almost forgotten something. We use a little symbol, and it's this symbol here, this little arrow symbol, to say that these two lines are parallel. So now you know if you see this little symbol on two lines, you know that they're parallel. Now I'm going to draw in my transversal. A transversal is just any straight line that crosses parallel lines. So there it is, there's my transversal. Call this my transversal. Now, the very, very first rule that I want to talk to you about with angles and parallel lines is called vertically opposite. And the reason it's the one that I want to talk about first is because it actually doesn't even have to do with parallel lines. all it has to do with is two straight lines. So for example, this straight line here and this one here. Or this straight line, the same straight line, the transversal, and this bottom one. And a vertically opposite angle is an angle that is opposite to another angle. So for example, these two here. Or these two here. Now see how I've drawn two little curves on this one instead of one. And that's because I want to make it clear that they're different. They do not equal the same thing. So vertically opposite angles, like this one here and this one here, or this one here and this one here, are equal. And we know that they're equal. It makes sense for them to be equal if we look at it, because my transversal here is perfectly straight. It doesn't bend. And neither do either of my parallel lines. So this transversal must touch this parallel line at the same angle as it leaves it. It's never bending, it's never changing direction. So it must enter it at the same angle as it leaves it, which makes a lot of sense. So we know that this angle here and this angle here and this angle here and this angle here are equal. Now I've said a lot of this angle here just there. I said that phrase a lot. And that's why I wanted to name angles like I've done over here. So I might do that now. I'm going to call this here point A. And I'm going to call this one here point B. And I'm going to call this one here point C. And then this one can be D. I'll call this one E. And then finally, we'll call this one F. And if I need to name more along the way, I can. But I think that'll be enough for now. So, the next rule that I want to talk about after vertically opposite. Actually, before I go ahead, I'm going to show you a little shortcut. Because if I'm doing my working out, say I'm in an exam and I want to show that I know two angles, like this one here and that one there, are equal, but I don't want to have to write out every time that vertically opposite angles are equal, what I can do is I can just draw this little symbol. Looks like an X. And in fact, we call the vertically opposite rule the X rule sometimes. And that means that I am saying that I know these two angles are equal because they are vertically opposite. So I don't have to write it out every time. Now, the next rule I want to talk about is called the corresponding rule. So corresponding angles. And sometimes this one gets called the F rule. Might extend that up a little bit there, because it has to do with these two angles here. So a corresponding angle is an angle that is in the same position but on the opposite parallel line as another angle. So for example, this angle down the bottom here, I might name another point. We'll call this point G. So this angle here is named angle EDG. Angle EDG. Angle EDG is going to be the same as angle ABC, this angle in here. Now the reason we know that corresponding angles are equal is very simple. We know that these two lines are parallel. If this top line was a physical line, I could literally pick it up, and without having to bend it or turn it, I could pick it up and put it straight on top of the other line without having to change its direction or anything. And I know that this transversal is straight. That's the definition of a transversal line. So the angle that the transversal touches this bottom parallel line, angle EDG, must be the same as the angle that the transversal crosses the top parallel line, angle ABC. And it's not just true of the ones in the bottom left either. Angle GDF, this angle in here, is going to be the same as angle CB, and we might have to call this H out here, angle CBH. And this angle up here is going to be the same as this one in here. So this is why we use this little F symbol, because if I was looking at that angle there and this angle here, angle CDF, then they look like an F shape. Now these two rules are actually the only two rules that we need to work with parallel lines and transversals. The other two that I'm going to show you today are just shortcuts, is the best way to describe them. They're just ways for us to make our life a little bit easier. And the next one I want to talk about is the alternate rule, or alternate angles. And this rule is sometimes called the Z rule, because it looks like a Z. The reason we call them alternate angles is because they are literally alternate to one another. So alternate meaning opposite. So an alternate angle is an angle that is on the opposite side of the transversal and on the opposite parallel line. So angle CDF, this angle in here, is going to be alternate to angle ABC. Obviously, I've already labeled it, but this angle in here. Just in the same way as angle HBC, this angle in here, is going to be alternate to angle EDC, this angle in here, because they're on the opposite side of the transversal and on the opposite parallel line. And what we know about alternate angles is that they are also equal. So what I could say here is that angle ABC, this angle here, is the same as angle CDF, this angle in here. They are equal. Now, the reason I said that this one was a shortcut and really all we needed was these two is because this rule here, this alternate angle rule, comes about from just a little bit of logic. And I can show you that right now. So, if we know that this angle here, angle EDG, is the same as angle CDF because vertically opposite angles are equal, and we know that angle EDG is the same as angle ABC because corresponding angles are equal, then this angle in here, angle CDF, must be the same as angle ABC. I'll say that again. Angle EDG is the same as angle CDF because vertically opposite angles are equal. And angle EDG is also the same as angle ABC because corresponding angles are equal. So if those two things are true, then angle CDF must be the same as angle ABC. So we can say that alternate angles are equal. The very final rule that you need, or we'll call this one a shortcut, not a rule, is called the co-interior rule. And we sometimes call this one the U rule, because it looks like a U shape, or we could just as easily call it the C rule if we turned it on its side. So let's talk about co-interior angles. Now this is where we need to talk about this fact up here, that two angles that make a straight line add up to 180. Because what we know so far is that angle EDG is the same as angle CDF because they are vertically opposite. And we also know that angle EDC, this angle in here, plus angle CDF, this angle in here, add up to 180 because they make a straight line. Now, we know that to be true because we know that two angles that add up to make a straight line add up to 180. But what we also know is that angle GDF, this angle in here, is the same as angle CBH, this angle in here, because they are corresponding. If we know that that angle is the same as this angle, we could just as easily say that this angle in here, EDC, is the same as CBH. This angle is the same as this one, because alternate angles are equal. So if this angle, angle CDF, plus angle EDC, this angle, add up to 180, but this angle, angle EDC, is the same as CBH, then this angle and this angle, angle FDC, plus angle CBH, must also add to 180. Now I'm going to say that again quickly because I know I went a bit fast there and it was a bit convoluted. We know that these two angles, EDC and FDC, add up to 180 because they make a straight line. We also know that EDC, this angle, is the same as CBH, this angle. Point that way so you can see the C. We know that they're the same because they are alternate angles. If these two add up to 180, which we know that they do, and this one is the same as that one, then this one and that one must also add to 180. So we say that co-interior angles add to 180. And that is the last rule, or the shortcut, that we need. So, to summarize, the only real two rules that we need to know are the vertically opposite rule, the X rule, and a corresponding rule, which is the F rule. These two, alternate angles and co-interior angles, are incredibly useful, and we use them all the time. But actually, they just come about from a little bit of logic. Using these two, and this rule over here, the two angles add to 180, we can make those two bottom rules. Now, this looks really complicated on paper. It looks really difficult. We've got lots of numbers and letters and shapes and angles and lines. But if you think about it, all we're really saying is that angles are the same when the lines are the same. And that's all we really need to know. So, that's the end of today's lesson. We've gone through the 4 basic rules of transversals and parallel lines. Next lesson, what we're going to do is use them to explain things about triangles. A very simple and fundamental fact about the nature of triangles. So I look forward to seeing you then, talking to you then, and good luck.